Hello everyone. This project is called Predicting Most Time-Consuming Steps in Air Transportation Process. The project will analyze the data from a freight forwarding company in the air transportation industry. By analyzing the data of the company's Cargo 2000 system, which occurred in 5 months in 2016, the most time-consuming steps are going to be identified, and also the time spent in these steps will also be forecasted with time series forecast models. In the business process of a freight forwarding company, 3 smaller shipments from the supplier are consolidated and in turn shipped to customers according to Cargo 2000 industry standard. Cargo 2000 industry standard is an initiative of IATA, the International Air Transport Association, and it aims to deliver a new quality management system for the air cargo industry. The business process shown below is a structure of the whole process of delivering goods timely to the customers. Each of the transport legs, including incoming transport leg and outgoing transport leg, involves following physical transport service. RCS refers to check-in flight at departure airline. The shipment is checked in and a receipt is produced at the departure airport. DEP refers to confirm goods on board. The aircraft has departed with the shipment on board. RCF refers to accept flight at arrival airline. The shipment is checked, the document, and the shipment has been stored at the arrival warehouse. DLV refers to deliver flight. The receipt of shipment was signed at destination airport. A transport leg may involve multiple legs, and in this case, the number of segments per leg ranges from 1 to 4, and we're going to analyze both the segment and also the transport leg to identify the time-consuming steps. The scope of this project will focus on the tracking and tracing events, covering 5 months of business execution during 2016. Due to a time-based nature of the data, we are going to use a time series approach to analyze, and the whole process involves several steps and segments. We need also to confirm how many types of steps are included in the whole process. Second, the sequence of the steps to comply with the regulation. And third, the time for each step. Before we analyze the data, we need to explore the data. By exploring data, it is possible that we can find our focus to analyze. First, we explore the incoming transport legs. As for the sample company, there are altogether 3,942 freight has been shipped to the customers during the 5 months. The figure is shown after the outgoing transport leg. Although there are 3 small shipments from suppliers are consolidated into 1 outgoing transport leg, only incoming transport leg 1 had the same number of records as that of outgoing transport leg. So it is reasonable to reflect the completeness of the whole process. We analyze the incoming transport leg 1 because the record is complete comparing with the outgoing transport leg, and it should take more time comparing with the other two incoming transport legs. Then we go down to explore the segment under each incoming transport leg. Although there will be multiple segments under one leg, in our case, there are only 4 segments in one leg, both for incoming transport leg and outgoing transport leg. Segment 1, 2, 3 refers to the RCS, DEP, and RCF in the business structure, and DLV is the last step shown in the chart. As analysis below shows, the segment 1, which is the RCS segment, has the same number of records as that of the output of each leg. So the data of segment 1 would be typical for our analysis, because every time there is an output from each leg, the segment 1 will have a record. That means it occurs. If we go further explore the data, we find steps under each segment. In each segment, there are 8 steps altogether, but we only focus on the steps whose actual duration is longer than the planned duration. In segment 1, 4 steps below have records with an actual duration longer than the planned duration. Among them, departure segment 1, this step has the highest rate of overdue records. So it is interesting to know more about the records and trends in this step. When we explore further, we find that there are 126 airports involved in the transportation for the company in the step departure segment 1. But only 5 of them, 5 airports, account for 45% of the total delay. And airport 815 is the top one with the highest delay rate, so we assume it is the bottom leg of the process, and will take the data of the airport 815 as our target for analysis. Now we have identified our analysis area and include 572 records. But we have to transform the data so that they can be used for the analysis model. As there is no specific date or time information in the data, in order to make the time series models, a sequential of months is assigned according to the sequence of the record number from 1 to 572. We use month from 1950 January to 1997 August as the substitute of the sequence order of the records, which actually occurred in 5 months during 2016. Of course, other months can also be chosen for this purpose. And another thing to mention is that the real month in 2016 are also unknown, so any 4 or 5 continuous months in 2016 is possible. If the seasonality in the data exists, we can identify the characteristic, and when we can identify the exact months, we can use the seasonality to predict the future trend. A linear trend model is chosen as the base model. The response of the linear model is the forecast time for a future activity, and the predictors are the past time already taken for the past activities. We've made 3 analyses on trend, season, trend plus season. The analysis shows that trend plus season has the smallest RMSE and the smallest MPE in the training set. But in the test set, trend plus season is not as good as the trend in terms of RMSE and MPE, as the seasonality is obvious on the plot. Trend is the solid base for the analysis. We still want to use trend plus season as our best model in this case. The plots also indicated that although the high spikes occurs in the training set, there were fewer spikes in the validation set, which means in the recent activities. And also the spikes in the validation set is not as big as those in the training set. This might show that the time spent on this step has been decreased to some extent recently. The majority of the data in both training set and validation set is around 1000. So it is quite possible that in the future, most of the activities will spend time around 1000 minutes. To predict the most time-consuming steps in the air transport process, we have first identified the most time-consuming area, including step and airport, through data exploration. That is the departure step under RCS, checking flight at departure line in the incoming transport leg 1, and the airport is 8150. We choose the incoming transport leg 1 because the completeness of its record can represent the whole process, as the number of incoming transport leg 2 and incoming transport leg 3 has less records, and their records may not reflect some important trend of the whole process. And we also use the historical data in the key area, try to forecast the trend in the future. Finally, we explore the 3 time series models and choose the best one based on both the results of the analysis and the direct observation of the plot, which is also the reflection of the real data. All the information could be used by the management during the process of the decision making. Now, as Z of the process has been identified, if the management want to improve the efficiency of the process, they can use the data, for example, the average delay in the step, to compare with other companies or the benchmark companies to say if it is internal inefficiency